So welcome from my side as well. The talk of today that I'll be delivering is microservices for building an IDE, the innards of JetBrains Rider. And the idea of this talk is to go through some of the design decisions that we made while building this IDE and see why we made those decisions and how they came about and how they actually benefit from being in the IDE. So before we start, I quickly want to show you JetBrains Rider so you have an idea of what it is. So Rider is an IDE, which is the place where you do your typical coding. And what you'll see is that on the left-hand side, you have the typical solution explorer. I know in Visual Studio, for example, you'll see this on the right by default. In Rider, it's on the left. You can open up folders in there. You can open up code files in there. You can start coding. In code, you can start writing. If you mistype something, you will see that it will highlight that there's an error. If you forget something, it will also highlight that. And things will start happening once you type. So you will see that this thing is missing. There's things like a NuGet package explorer where you can basically search on NuGet, install packages into your project and so on. On the right-hand side, there's database tools. All of that stuff is in the IDE, and it's really an IDE for .NET developments that you can use in your day-to-day work. So the focus of this talk is not really to dive into what Rider is as a product that you can use. The idea is really to go into why we made certain decisions and how it came about and is what the IDE looks like today. Just so you know, Rider is cross-platform. It's a full-stack .NET IDE, so it works with all languages in .NET world, whether that's VB.NET or C# or F#. It also works with all of the frameworks, which means classic .NET Framework, .NET Core, as well as Mono if you're on Linux or on Mac. And if you want to do WinForms development on Windows, you can even do that with Rider as well. So that means that to make all of those things work, you will see later on during this talk that there's a couple of things that we had to do to make those actually work as well. It's fast, it's lightweight, and it's also a combination of two IDEs, namely IntelliJ IDEA, which is the JetBrains Java IDE. That's the front end that powers Rider. And ReSharper, which is the backend, so all of the C# and .NET code analysis that you will see is powered by ReSharper. And the idea of Rider is to be more productive as a developer and be able to do that cross-platform and have the same IDE on all of those platforms. Now, before we dive into some code and architecture and so on, I quickly want to give you some history of how ReSharper came about. So ReSharper and IntelliJ and so on are products of JetBrains, the company that I work for. And JetBrains was founded in the year 2000. And it actually started with a very, very simple tool called IntelliJ Renamer. And IntelliJ Renamer was a tool that would allow you to open up a Java class and rename that class, and it would rename all of the files and update all of the references and so on. So a refactoring as a tool, as it were. Now in 2001, we decided to make that IntelliJ an actual IDE. And in the year 2004, we also introduced a second product, namely ReSharper. Now the reason for that was that somewhere in 2002, 2003 timeframe, another IDE came to market in the Java space, which was Eclipse. And JetBrains decided, well, we can no longer do just this Java IDE, IntelliJ. We also have to come up with ReSharper and so on. Now, ReSharper was developed in C# and was developed on .NET and is a really separate product and from IntelliJ. And it still exists today. IntelliJ itself has evolved into over 20 IDEs today, all based on the same core. So IntelliJ is really the IDE powering things like WebStorm, PHP Storm, Android Studio if you're using Android Studio, and so on. So there's quite some IDEs based on that IDE. On the ReSharper side, this was actually ReSharper back in 2001. So ReSharper is a plugin to Visual Studio, but back then we did not yet know whether it would be a plugin to Visual Studio or an actual IDE. So we decided to build both. This is the ReSharper IDE from back then. Built in WinForms, you can see that we didn't even bother updating the icon in the title bar there. But the idea of this IDE was to provide everything that IntelliJ could do for Java, do the same thing with ReSharper for .NET developers. So you see Solution Explorer, there's documents in there. Inside of those documents, that's quite cool. You can see the doc blocks rendered as a nice, well, the color is not that nice, but you can see it rendered not as XML comments, but as an actual block and an actual graphical thing. There's find usages in there. So all of the things that you know and love from ReSharper and maybe Rider were already in there at this time. Now, when we released ReSharper, we decided to not ship it as an IDE. So the ReSharper IDE standalone was halted as a project, but it has not gone to waste. Because at that time, we did not know that whether we would be a plugin or an actual IDE. The IDE for ReSharper was built with several concepts and architecture decisions back then. One of those decisions was to keep functionality separate from the actual IDE. So that means that while ReSharper has the same core for doing refactorings, for doing code analysis and all that, all of that is there. The IDE interoperability layer is something that sits on top. So all of the Visual Studio integration is something that connects to that core that is in ReSharper. So even though it was an IDE back then, the plugin and the IDE were basically the same core, just with a different front end on top of it. That also allows us, even today, to still target Visual Studio 2010. So if you would install a recent ReSharper version to Visual Studio 2010, that would all still work, and it works with all of the versions in between. And I don't know if anyone is using it, but there's also the ReSharper command line tools that you can run on a build server, for example. Well, that is also ReSharper. It's the same code base. It's just that the UI is, or the interface to the code base is a console application that gives you command line tools there. Now, at many of the conferences that we exhibit at, we have a booth. And at the booth, you very often get questions from people. And one of the questions that we got a number of times was that, when is JetBrains going to do their own IDE? That was a question that we got quite often. And that's one of the reasons why we decided to start building our own IDE, namely Rider. So why would we build a .NET IDE? First of all, people were asking us for it. Second of all, because ReSharper is getting more and more constrained by the Visual Studio environment. And it's not a blame game. It's really that VS is a 32-bit process. Visual Studio is in there, Roslyn is in there, ReSharper is in there, and 32-bit processes don't give you a lot of memory on .NET. You typically exhaust the memory space around 2.1 gigabytes, more or less. So that's an issue. Also, the fact that Visual Studio started doing these yearly and many times a year releases for Visual Studio means that there's lots of changes going on, and sometimes they impact ReSharper, and we can no longer be as quick with adopting those changes. So we decided, okay, maybe let's do our own IDE, so at least we also control that part of the equation. Back when we started discussing Rider was also the time that there was not a good .NET Core IDE that was good and also consistent cross-platform. We decided, okay, we can build an IDE that works on Mac, Linux, and on Windows, and is the exact same IDE, same UI, same way of working with it, and so on. So we decided, okay, all of those things combined, let's build a .NET IDE. Now, the fact that we wanted to make a cross-platform IDE means that we also would need a cross-platform UI toolkit. Since ReSharper is built on .NET, we would need something that could render the ReSharper UI elements cross-platform. Could be WinForms, but of course WinForms doesn't work on Linux and on Mac OS X. WPF, same story, would not really work. So if we would build ReSharper cross-platform, we would need to convert our UI to use something like GTK Sharp or Qt or something like that. Or if we would go the very hacky way, we could do some WinForms on Mono, because that sort of works, but also not ideal. So in essence, we would have to come up with a cross-platform solution for UI with ReSharper. Then we started thinking. We already have this IntelliJ IDE, which works on Linux, which works on Mac OS X, which works on Windows, and so on. We already have a number of other IDEs built on top of that one. So we have all of those IDEs, PHP Storm, PyCharm, RubyMine, WebStorm, and so on, built on top of that. And they also work cross-platform. Instead of rewriting the UI and so on for ReSharper, what if we could use IntelliJ as the UI for everything that we already have? And we decided to look into that as well. IntelliJ, the IDE, is actually the IntelliJ platform. So IntelliJ Platform is the thing that powers all of our IDEs. It's open source and it provides the base IDE, which has a project view, code completion, an editor, the UI toolkit, and so on. And for every IDE that we ship at JetBrains, we basically build a plugin on top of that IntelliJ platform and ship it as an IDE. If you're very adventurous and you want to build your own IDE at some point, which Google did with Android Studio, which Comma IDE did for Perl, I think. So there's a couple of open source IDEs built on top of IntelliJ out there as well. If you want to build your own one, you can go to the repo there on GitHub, download it, and build your own IDE on top. You can do that. It will be cross-platform because it's all JVM-based. It runs on Windows, Linux, and Mac, which is nice. Now, we decided to look at that IntelliJ platform to host ReSharper, but the thing is, if you start thinking about all of those things, IntelliJ is JVM-based and ReSharper is all .NET-based. So how can you combine those two things in one project? Yes, IntelliJ is cross-platform, and yes, ReSharper could run cross-platform if we use Mono or .NET Core or something like that, but they are two different platforms. One is JVM, one is .NET. How do you solve that issue? Well, we had a couple of options. One of the options that we had was to maybe rewrite ReSharper in Java. ReSharper back then was already 16 years old, and we decided, well, maybe it's not a good idea to do the big rewrite, as you would say, the big rewrite of ReSharper in Java, because that would mean that we, first of all, would throw away 16 years of implementation and knowledge, but also we would be bringing two ReSharper implementations to the world. We would have one in .NET and one in Java. That's probably also not ideal. An automatic conversion could be some option as well, where we would convert some of the C# code into Java at some point, but we decided maybe that's not a good idea. The other option that we thought of was to maybe run ReSharper as a command line process out of process, make it possible to run ReSharper headless, and then build our own UI on top. Well, the fact that we had that ReSharper IDE back in 2004 means that we already had a number of abstractions ready that would allow us to do this and run ReSharper as a command line process with our own UI on top. And that's what we decided to look into, IntelliJ plus ReSharper. Headless ReSharper as a language server for the .NET parts. Cross-platform could be .NET on Windows and .NET Core on macOS and Linux. No constraints for Visual Studio because we run in our own process. It can be ReSharper because we already had those abstractions, so it's really the same code base powering both ReSharper as well as Rider. And then on top of all that, we would plug IntelliJ as a thin UI controlling that headless ReSharper process. Awesome. Decision was made. We decided to build our own IDE. Now, if you start thinking about things, are both sides really what we thought they were? Is IntelliJ IDEA really a thin UI, or is it really an IDE? Turns out that there's actually three sorts of features in IntelliJ and ReSharper. There's features where IntelliJ can handle everything. There's features where ReSharper handles almost everything. And both IDEs are really two IDEs, and they can together make a more awesome IDE, which would be Rider in turn. So IntelliJ IDEA is not really a thin UI. It's really an IDE on top of another IDE. So we decided, okay, how can we work with that and maybe leverage features from both IntelliJ as well as ReSharper in Rider. So I'm going to give you a quick example of where this combination becomes visible. So if you open up any projects or any solution in Rider, you can see that, for example, if you do a web project, you will get Razor syntax as well as HTML. The cool thing is that in Rider, this Razor syntax is all C# and is handled by ReSharper, whereas all of this HTML is handled by the front end, by the WebStorm IDE that is actually sitting in the front end of Rider here. So everything I do here in terms of completion, and for example, if I would create a list that contains, let's say, 50 elements, and then in there we have a P and there's a link in there. If I tap there, this is handled by WebStorm. This is handled by the front end, and all of this is generated as HTML by the front end, while I can still mix in and sprinkle in some C# to handle all of the Razor syntax. So it's really two IDEs powering one experience. Same thing happens in code. We have a database connection that sits in IntelliJ. We have C# code that is powered by ReSharper in the backend. What you will see is if you start writing raw SQL queries or raw entity framework queries, you will see that inside of a string, you get code completion for a SQL database that you are connected to. So all of the C# that you see here is powered by ReSharper, whereas this string content, the fact that you can have code completion for elements and fields and records and so on from your database, this is all powered by IntelliJ, by the front ends, by the features coming from data grip into the front end of our IDE there. So the fact that you can have two sides of the IDE, both working together and doing the same thing, and I should log in there, I'm going to cancel that. The fact that you have those two IDEs operating together and working together to give you this experience is kind of nice, because yeah, you really get the best of both worlds. There's a couple of other places where there's one feature that is not in ReSharper, and that is local history. Local history is like a undo on steroids. You will be able to see all of the changes that were made to specific files, and you can basically revert to any point in time when you want it. And apparently I made a lot of changes to this file, so it might take a while to load. But at some point you will see that I can restore changes to the file that I have there. Actually, history is empty. Let's change that and make a quick change so you can see what I mean. So let's add a change, show that thing in action. And you will see that once it's loaded, it should give me back the entire history of what I've been doing there. Anyway, in the interest of time, I'm going to skip this thing, but trust me, this works. It's really undo on steroids and allows you to push back changes that you made throughout the day without having to commit them to the to source control. The cool thing is that it's all powered by the front end, this local history. ReSharper doesn't even intervene there, which is, again, a nice example of the fact that you're actually working with two IDEs at the same time. Cool. So how would we make those two IDEs talk together? How could we make IntelliJ talk to ReSharper? How can we make ReSharper talk to IntelliJ? Well, the data types that go over the wire, connecting the Java frontend with the .NET backend, are not that complex. If you think about context actions where you Alt-Enter, you see this light bulb, and you want to provide a list of actions that you can do in the editor, basically you could represent those context actions as a tree of just names and icons. Same things with inspections. If you see those squiggly lines in the editor, what you can do is pass a set of names, icons, a severity, whether it's a warning or really severe error, maybe a tooltip, as well as the position in documents. That would be the data. You don't have to pass or remote objects into the front-end process. You can just provide that small set of data, which is the name, icon, and the tooltip. Same thing when writing code. If you're writing code, which you typically would be doing in the front end, you're writing code in the editor, well, you can give that code to ReSharper by simply not giving the entire document, but just giving all of the changes. You provide a delta with which line and which column you're actually making a change, and you give the text that has been inserted so ReSharper can also analyze that as well. So all in all, the communication between front-end and back-end are fairly simple messages. They can be made quite generic. So if we could make one inspection work, all of them could work. And if we could make a mechanism where we could simply pass along a set of names, icons, and severities, well, we can make all inspections work in Rider as well. So which protocol do we use in Rider? Well, we started looking at a number of protocols. So there's, for example, the language server protocol that VS Code is using. We have looked at that, and it's a great protocol in itself. It has IDE concepts like a window where you have an editor. You can have languages in the editor. You can have diagnostics where you pass along those inspections and so on. It's really great. All of that is in language server protocol, except that ReSharper has more things than would fit in the language server protocol. So if we would want to make sure that all of the ReSharper functionality was surfaced in the front ends, we would have to extend the language server protocol if we were to use that. And that's possible, but if we would have to extend the language server protocol anyway, why not build our own protocol? So we decided to also look at a custom REST-like protocol where we have the front end making a request to the back ends and then the back end responding something to the front ends. We experimented with various serialization mechanisms. We tried JSON, we tried protobuf. We did a request response style protocol basically to make the two communicate. And it kind of worked, but it all felt a little bit sloggy. It felt not as fast and fun to work with as we would like to see it. We then started to look at why would we even use a request action response kind of cycle? Why would we use something that is language server protocol like? And why would we have a custom protocol that does a request and handles and does something and then gives back a response? If we use a request response type of protocol, every call that we make from front end to the back end would need context. Which solution did we open? Which project are we in? What's the file that we're currently looking at? What's the location of our cursor in code and so on? So all of that context would have to be part of the request so that the back end would know what to do with it. And then we realized, well, why do we even need that context? Why do we need that request action response flow? Why do we need this remote procedure call mechanism? Since both IDEs are built by JetBrains and they were built with the same philosophy, they all share a similar model and architecture. We have a project that has documents and each document has text ranges and so on. It's the same in IntelliJ and the same in ReSharper. So why would we even build a request response flow? What if we could have very simple messages that could just transfer the states from backend to frontend and from frontend to backend without having all of that overheads? So that's when we started thinking about model view, view model. IntelliJ could be our view, ReSharper could be the model, and the protocol itself, the communication layer between the two of them could be the view model, sharing just lightweight data. And that's actually what we conceptually thought of building, which was what if we could have an object that is called projects. A project can have files, and we can add files to a collection. If we could model this in frontend as well as on backend and make sure that the two know what the state is of our view model, then we're pretty much done, right? The protocol is not as simple as the one you would see on the slide here, but the idea still remains. We would have a project view model that has files as a collection, and we can add files into it, and somebody can react to that and maybe do something with it, such as running code analysis and so on. Right, there's one thing that remains. Even if we would use this model view, view model structure where you have multiple sides of the equation, there's one thing that remains, and that's conflict resolution. If you make changes to such a shared data model, those changes can come from both sides. You as a developer may be typing in a file while ReSharper is doing a refactoring. Well, if the refactoring completes after you already typed something, who is winning? What's the conflict resolution that you're going to adopt there? We looked at locking. So like when you're doing editing, for example, put a lock so you can't do a refactoring. We quickly decided that's not a solution because you get freezes, you get deadlocks, and all of the things that are common with locking. So we decided to come up with one very simple convention, which is when one of the sides updates the view model, every change comes with a version. We increment the version number. If you are doing something and you get a change from the other side that has a newer version or the same version, then we can apply it. If not, the change is discarded and both sides have to remodel everything and make sure that everything is up to date. So very simple convention, pretty much last one or newest one wins, so to speak. Right, let's talk about the actual protocol. The protocol itself would be something that communicates between the IntelliJ platform and ReSharper. And we decided that our diagram or our architecture would pretty much have to be something like this, where all of that communication would be magic. Ideally, none of our developers would have to know the details of the fact that there's this protocol in between. They should just be creating those view models and work with those view models throughout their development day. So this is what the protocol looks like conceptually. It's slightly more complex than that, but when you're using it as a developer working on Rider, it is really magic and things just work to communicate between both sides. The Rider protocol itself is a distributed communication framework that currently works in .NET, Kotlin, JavaScript, and C++. You may wonder why C++ if you're just doing Java and Kotlin and .NET. Well, C++ because last week we released Rider for Unreal Engine, which is all C++, and there's some C++ processes involved there as well. So we extended the protocol to also work there. It is open source. You can use it in your solutions as well if you need a similar type of protocol. And what you will see when you start using it is that it's really a stack of things. There's sockets, there's batching, there's a binary protocol of what goes over the wire. On top of that, there's the conflict resolution, the serialization, and things like that. All of those things you don't really have to care about as a developer. The protocol abstracts those things and makes sure that the model that you define using a DSL, a domain-specific language, is the thing that goes over the wire and exists on both sides of the product there. And then you build .NET code, you work with a .NET code generator. If you want to communicate with it using Kotlin, you get a Kotlin code generator that translates that model definition into actual codes that you can be using. Right. So the protocol, our developers only need to know about those few data types that are in there and work with the model. They can build that model, they can create classes in the model, and the model will reflect what the protocol will look like. The things like conflict resolution, the actual wire protocol, timeouts, the fact that you can have disconnects and so on, those are all handled by the library that we created. The code that you generate based on the view model is generated in the language that you are using, which means that since it's generated, there's no reflection involved, there's no JSON, ignore, and whatever attributes. It's really just C# code or Kotlin code that you work with that handles everything and that you can use to communicate between both sides of the IDE. It's also hierarchical and introduces lifetimes. That's a very vague statement, and I'll go into that in a minute. Architecturally, the protocol uses signals and events. A signal is basically, I have an interface that I can fire an event to, and then there can be a sink listening to that event. And an event is a combination of something that happens and something that reacts to something. So that's pretty much the philosophy of everything in the protocol. So if in the protocol you would work with a list and add items to a list, those are all basically lowered down to just these three types of interfaces. You can also have properties that have values. So you can have a property on an object that has a value string, for example. That's really a combination of an event and so on that happens, and to a property you can subscribe to it, or you can see what the current value is. All details, I'll go into that a little bit later in an example. There's some primitives in the protocol as well. You can have signals, something is happening, I want to fire an event. There's properties where you can observe a value. Properties can also be lists, sets, and maps, and so on. And there's the typical data types that are bytes, shorts, integers, long strings, and so on. Having that said, I'll quickly show you what the lifetimes are about, and then I'll show you some code of how this works in practice, because I know the slides are probably less clear than what would be in code. One important thing to know in an IDE is that everything has to be hierarchical, and you have to lifetime your resources. In a typical application, you can make use of disposables, for example, and put a using statement around something, and when you're done working with something, that object goes out of scope, or you call dispose and the object disappears from memory. In an IDE, typically your objects will be longer lived. If you open up a solution and I work with that the entire day, well, the object representing my solution will probably be around the entire day. So the last thing that I want to have in code is a big using statement around my solution, because I'm never going to exit there unless I close the IDE, right? So we decided to work with lifetimes, and lifetimes are an object that you can bind to. So if you have a disposable, instead of putting a using statement around it, what we do is we attach it to a lifetime as a disposable, and when that lifetime is disposed, we dispose all of the child objects there. Visual, you could think of it like this. If you have a solution that is open, the NuGet host in there attaches to the solution lifetime. If you have a project, that thing attaches to the solution lifetime. Document attaches to the project lifetime and the solution lifetime, etc., etc. So hierarchical, and you attach them all to a lifetime, which means if a document goes out of scope, the solution, the NuGet host, and the project remain in memory, but everything else can be discarded because that lifetime is closed at a certain time. The protocol extends this by also making the lifetime work cross boundaries, which means if in IntelliJ you close an editor tab, we will also close the lifetime in ReSharper, and that document in the backend will also be closed. So there's basically memory management going on the protocol between the two sides of the equation. Anyway, let's quickly dive into some code so you can see this in action. Right, in Rider, if you've ever worked with it, you will see in the NuGet tool window that there is a log tab. And in the log tab, we basically output everything that we can write there, probably too much sometimes even. But what we log there is which credential provider is being used, what is happening when you do a package restore, some debug information so you know what is happening on the background there. Well, the NuGet restore itself is handled on the ReSharper side of things, whereas, of course, the displaying of this log is happening on the IntelliJ side of things, where you see what is going on in there. So somewhere in our code base, we have to model a log that I can write to from ReSharper side and can consume on the IntelliJ side. And that is what this is. So what we have in the protocol is we have a model written in Kotlin where we say, look, this model has a sink, something that accepts RD NuGet log messages on a property called log. This is the protocol model definition where I define that I want to have an object in the protocol that will handle NuGet log messages on a property called log. We then generate code based on this, and we generate Kotlin codes that we can use in the IntelliJ side. And if we search for our log in there, you will see that at some point there is going to be a log property that is generated based on that protocol definition that we just made. And this log is a list of RD NuGet log messages. Instead of having something that is specific to the protocol that we designed, you will get a traditional list that you would get in traditional Java and Kotlin as well on the IntelliJ side of things. On the ReSharper side of things, and I have ReSharper open in Rider. On the ReSharper side of things, we also generate code, but this time we generate it in C#. And here also we get a list that has RD NuGet log messages. The cool thing is when we then plug this logger, when we plug this protocol into NuGet, what we can do is make use of our NuGet host, which is sitting on the protocol. And whenever NuGet logs something, which is this logger base interface, when NuGet logs something, we fire it into the protocol. And we say, look, in this log, we are adding a new NuGet log message with a certain string. That's all we have to do on the ReSharper side to pipe logs from NuGet into the protocol. On the UI side of things, again, in IntelliJ, we have a NuGet log panel. And this log panel is the UI that listens for events that are happening in the log there. We have that log property and we subscribe to it. It's like a reactive extension kind of thing where we subscribe to this log and we say, okay, whenever messages come in, we add those messages into the UI so they get rendered. So as you can see, this is a very, very simple way of doing things. I have a view model. I add messages on one side of the equation, and I consume them on the other side. And I can also do this vice versa, where, for example, IntelliJ could pipe something into that log property, and I could use that on the ReSharper side of things. So this is roughly how the protocol works. You define the model, generate code based out of that, and then you can start developing with it and just pass data over the wire, and the protocol takes care of everything that is underneath there. Right. So it's very extensible. It's a Kotlin-based DSL. Our developers don't really have to know a lot about the protocol. They can simply create that model, generate code based of it, and then work with the code that they generated. There's no real need to think about multiple processes. There's no real need to think about the fact that there may be network connectivity issues and so on. It all just works, create the model, and you develop against that model. If you're interested after this session to look into how this works, there's 2 plugins, the Unity support in Rider as well as the F# support are open source. Go and have a look, because those 2 also extend the protocol and also communicate between backend and frontend in the plugin. Obviously, having those 2 sites, having that JVM world and that .NET world also means that writing plugins for Rider is slightly more complex than writing one for just VS, for example, or just Rider, or just IntelliJ, or just ReSharper. Anyway, have a look at those, because it's really nice if you see it, you define the model, and things get generated out of that. Right. I promised that this talk was going to be about microservices in the IDE as well, because the title said microservices. I have 8 minutes left, so let's talk about microservices finally. Since we have 2 sites in the IDE, that is Rider, we have 2 processes. We have IntelliJ as a process, which runs on the Java virtual machine. We have ReSharper running on .NET or .NET Core on Linux and Mac OS X. And each of those 2 processes has their own 64-bit memory space and also their own separate garbage collector. Multi-core machines will benefit really greatly from this thing, because if you have a multi-core machine, IntelliJ can use some cores, whereas ReSharper can use some other cores, and those things will work together. We can start and stop those processes independently. Actually, if you just open Rider and you see the welcome screen, the ReSharper process typically has not yet started at that point. It's just the IntelliJ side of Rider, and once you open a solution, ReSharper will start and you attach to it. Starting and stopping independently also means that both can crash independently. So if something really goes wrong, we can still have the front end running, we can recover the back end, and something can happen to make things work again as well. If you are debugging in Rider, you're actually using 4 processes. You still have Rider, which is IntelliJ and ReSharper. You have your debugger worker process, which is a process that we run to communicate with your application. And of course, if you're debugging, you also have your application running. So there's communication happening between 4 processes at that time. So 4 microservices, so to speak, contributing to the same experience. We decided, okay, or we started thinking, if we have those multiple processes running on one machine to do debugging, how can we make this even cooler if we would spin up additional processes, share the protocol between all of those processes, and introduce more microservices in the IDE? So we did. What if certain features were running in their own process? If you are using the XAML preview in Rider, what you will see is that IntelliJ will run, Rider will, or ReSharper will run on the backend as well. And the rendering you see, the preview of the WPF of the XAML that you're writing, is actually something that is generated in a separate process. It's again a new process. And it's not that we have a request response style mechanism there either. No, we have ReSharper communicating with that previewer process, and it shares the same protocol that it does with the front-end IDE, which is kind of cool. The view model is or can be shared between multiple processes. So there's another feature in Rider where you can also load Roslyn analyzer. So if you have your own inspections, for example, that are written in Roslyn, you can run them in Rider. Well, we share the model of inspections between IntelliJ, between ReSharper, as well as our Roslyn analyzer process. If a Roslyn analyzer fires and says, look, I have an inspection to report, something is happening, I want this icon, this severity, this tooltip, and this is the text range in the documents, well, it simply can add that to a collection of inspections, and ReSharper will see this, and IntelliJ will see this as well. So we are sharing the view model between processes. You will actually see that as well. If you have Roslyn running in Rider, you will see that you get Roslyn quick fixes. But if you would look at the processes in your IDE, you will see that you actually have multiple processes running, which would be Rider itself, the ReSharper host, and then you get the Roslyn worker running there as well, contributing the Roslyn inspections. The fact that we have that protocol and the fact that it is a socket-based wire protocol means that we could also theoretically run the protocol on multiple machines. And that's also something that we are doing. if you're running Docker debugging or remote debugging, we actually pipe that remote debugger process into a separate machine, listening to your application, communicating with your application, while Rider is still communicating with that process remotely. So if this works with Docker and remote debugging, well, maybe we can even run it across the Atlantic Ocean and have a debugger process sitting in the US where we connect to it from a Rider instance running in Europe. So that could work in theory. If you look at the Unity game engine support that we have in Rider, you will see that we are also heavily extending the protocol there to make a really rich experience between the Unity editor as well as whatever we have in Rider as the IDE. So when you run Unity in Rider, you actually have Rider communicating with the Unity process. Unity communicates with your application. We can also debug and communicate with your application and combine all of that into one service. So this protocol, it's not that we have a point-to-point protocol where you have to do request response between every single party that is involved here. No, we again have only that one view model that everyone contributes to and that everyone can do something with. Actually, this is a nice demo of how this could work. So what you will see in this demo is that we have Rider running. And in Rider, we can do a find usages. And the usages that will be found will also be shown in the Unity editor. And this is really adding a couple of items to a collection and switching focus. So if you would run this, you would see in Rider, we do find usages. We select the usage and it pops open in the Unity IDE, which is kind of nice because all of those things can combine or can work together using that exact same protocol. Right, so I think I'm going to go over time for 2 or 3 minutes, but bear with me, almost there. The fact that we have this protocol, the fact that we have those microservices in the IDE also means that looking at the future, there's a couple of interesting use cases that we could be using in Rider. One of those use cases, and that's one that we're actually already using, is to also model the view on the protocol. Instead of having to use Swing in the IntelliJ side to draw the Java IDE and in the ReSharper side, instead of having to use XAML, what if we could model the view as a protocol model and then generate a view based out of that? And that's what we do. So if you go to the C# interactive options in either in Rider, that is actually generated based on protocol messages where we basically say, okay, look, we have a header, we have a toolpath selector, we have an empty line, we have another header, some Boolean options and so on. And based on that, we generate the view as well. There's a couple of features in Rider and ReSharper where we are already using this approach to have the same UI in both ReSharper, the plugin to Visual Studio, as well as Rider, the standalone IDE. The fact that we can communicate across machine boundaries also means that we could do interesting things. And by the way, none of these things are working today, but they're just thinking about what we could do with the protocol. What if we, on a Mac OS or on Linux, could do the rendering of a WPF preview on a Windows machine while you are developing on your Mac OS or Linux machine? Using the protocol, using this microservices-based architecture, we could do this in theory. We could run the front end of the IDE on one machine and run the back end on another machine. So things like doing a live share kind of thing could also become possible thanks to this protocol. A really interesting thought experiment that some folks in JetBrains did was, what if every IDE would be both a client and a server to the protocol? What if ReSharper, sitting in Visual Studio, could make use of WebStorm's HTML, CSS, and JavaScript functionality? That's an interesting one. I don't think this one is going to happen, but in theory, using this protocol, using this view model, and having multiple contributors to it could mean that we can actually pull this off and make that happen. So to summarize this talk, I would say that Rider is an IDE built on top of 2 IDEs. We're actually leveraging the 2 IDEs in the IDE itself. Also 2 technology stacks, JVM and .NET. And we have to have a rich and easy programming model for our developers to work on both sides of that stack. The fact that we built that protocol also gave rise to the fact that we could run multiple processes to contribute to the same view model. and that we can also have more than one machine contributing to all of those things. And even we could do micro UIs where we generate a UI and have that piped over the protocol. With that, I would say thank you, and